often think of art and science as two separate things, but there is actually a lot of chemistry involved in formulating paint. Things like how paints mix and how fast they dry are determined by molecular interactions between the paint's components as well as the canvas. Let's look at the basic recipe for any kind of paint. There's a pigment, binder, and solvent. Pigments are the color, the star of the show, and they come in powdery solid form, which isn't something you can easily paint with. Adding pigment into a liquid called a binder, or a carrier, allows the color to be evenly distributed and stick well to your canvas. That's because of intermolecular forces, or IMFs. They're electrostatic forces that hold molecules together or draw them apart. We can understand these forces by tracking down the electrons. Due to a property called electronegativity, electrons tend to congregate around certain atoms more than others, creating areas of different charge in a molecule, making it polar. That molecule's positive end will be attracted to another's negative end. These are dipole-dipole forces. The greater the charge, the stronger the interaction. So that's how our paint binder works. All the paper molecules being attracted to all the slightly charged binder molecules like a bunch of tiny magnets. This is called adhesion and is how some glues work. In acrylic acid, which is used to make the binder in acrylic paint, there are two oxygens drawing electron density away from the hydrogen, making it really positive. These particularly strong IMFs, when hydrogen is connected to a very electronegative atom, are called hydrogen bonds, and are how acrylic is able to adhere to a lot of different surfaces, making it a popular paint. However, on their own, your pigment and binder may be too thick to paint with, or you might want to dilute the color. This is where solvents or thinners are mixed in to give your paint the color and consistency you want. When choosing a solvent, its interactions with the binder have to be taken into account as well. You know how oil and water don't mix? That's because unlike water, oil is nonpolar. Nonpolar molecules are symmetrical and therefore don't have differently charged ends, so they interact with each other through minuscule instantaneous fluctuations in electron density called London dispersion forces, which are much weaker than dipole forces. So the water molecules are more attracted to each other's strong hydrogen bonds than to nonpolar oil molecules. You wouldn't want that to happen in your paint. So if your binder is oil-based, you have to use a solvent that is also an oil. We've painted something, now it needs to dry. When paint dries, it's actually the solvent that is evaporating, leaving behind the binder and pigment. Solvents are able to evaporate easily because the IMFs holding them in solution are weak enough that they can escape into the gas phase. This is why you should paint in a well-ventilated area. You don't want to inhale too much of the solvent. So there are a lot of interactions going on in this little tube of paint. These IMFs are what chemists and engineers have to think about when formulating things like medicines, glues, cleaning products, makeup, and more.